I definitely started the broadcast. Oh, I have to show my screen.
Oh, grab my coffee.
All right, ready? Or he's going to come back in. Steve's going to have to cut all this out. I started recording. Hi, Steve. We're here. I think for spacing. Oh, see, I would understand that. All right, ready, guys?
Okay.
Good morning, everyone. I am Caitlin Meyers, Training Coordinator at Sustainable Solutions Corporation, and thank you all for joining us today for Advancing Your Business with Lifecycle Assessment. After completion of this course, you will receive 1 professional development hour credit towards your professional certification. And just a quick reminder that this presentation is copyrighted. The purpose of this course today is to help you demonstrate the value of lifecycle assessment, or LCA, to foster sustainable products and reduce environmental impacts. At the end of this presentation, you will be able to understand the growing demand to quantify and publish lifecycle environmental impacts. You'll also be able to understand how lifecycle assessments are a core component of a sustainable product innovation program. You'll improve the environmental performance of a product beginning with product inception. Utilize lifecycle assessment data to evaluate products and suppliers. And finally, utilize lifecycle assessment data to improve operations and reduce environmental impacts. We have 2 great presenters today. The first is Jim Melentine, Corporate Sustainability Manager at Sustainable Solutions. And Jim is a Lifecycle Assessment Certified Practitioner. He works with organizations to refine and execute their corporate sustainability strategy. Jim also teaches a graduate course on lifecycle assessment at Philadelphia University. The second presenter is Kara Watson, Sustainability Specialist at Sustainable Solutions. And Kara is a Lifecycle Assessment Certified Practitioner as well. As a member of Sustainable Solutions Corporate Sustainability Team, Kara provides lifecycle assessments and other services to a diverse group of clients. As a reminder, today's webinar is being recorded and the link will be sent to everyone. Jim and Kara will be happy to answer your questions towards the end of the webinar, so please feel free to send them through the pane at the side at any time. And now, here's Jim.
Thanks, Caitlin. So first of all, what I'm going to do is start off with a little bit of an overview of Sustainable Solutions. And we have 3 main businesses here that we offer at Sustainable Solutions. And the first is corporate sustainability, where most of our lifecycle assessment work takes place. But it's also at a much higher level. We help organizations and manufacturers really try to reduce the environmental impacts of their products and operations and realize cost savings at the same time. We also have a division that focuses on sustainable buildings and operations, and they help companies achieve LEED certification, National Green Building Standard certification. They do Energy Star benchmarking and a host of other consulting services. And then finally, because we know that training and education is critical to a successful sustainability program, we do help companies train their employees, such as sales and marketing teams, research and development teams, operations teams, and others as well, to help people understand what their role is in your sustainability program. All right, so let's just get into it. And I just want to give you a brief outline of how this is going to work today. I'm actually going to talk about what lifecycle assessment is and how you can execute a lifecycle assessment at your organization. And in the second half of this presentation, Kara is going to talk about why an LCA is useful and what companies are using it for today. So what is lifecycle assessment? Well, it's really a way to quantify the environmental impacts of a product, process, or activity over its entire lifespan. So there are some traditional life cycle stages that people usually talk about when they talk about the life cycle of a product, and that is extraction and processing of raw materials, the manufacturing of that product, various instances of transportation and distribution. Also, the product is used, it may be reused or maintained over its lifetime. And then finally, once it reaches the end of its useful life, it's disposed of in some way. That may be in a landfill or recycling, it may be incinerated, or other scenarios as well. But let's look at an example in the real world, just so people can get a better understanding of what I'm talking about. So let's look at a piece of door hardware. And everyone's familiar with door hardware. This could be a hinge, a lock, a doorknob, maybe some type of more sophisticated electronic access system at your company. But a lot of these door hardware products contain similar types of materials. So you have things like brass, aluminum, steel, nickel, and all of these are metals that need to be mined and then refined from their ore and sent to a manufacturer for further processing. So, but you may also have some plastic components, and that would require natural gas or oil inputs. You might have, for electronic access systems, you might have wire that would require copper and PVC jacketing. So various materials need to be extracted from the earth and refined in some way before they even get to the manufacturer. And all that extraction and refining takes energy and materials to do. And all of that has an environmental impact. Once it gets to the first step in the manufacturing, that's manufacturing the different components of the door hardware. There's various types of machining and either CNC machines or other precision machining methods where they actually take the metal and plastic and other materials and make these tiny little components. And door hardware, depending on what it is, may have just a few components, may have dozens of components, maybe even hundreds of components. And then once those components are made, it gets shipped to another facility for assembly, or maybe it's assembled within the same facility. And both of those steps take materials and energy and generate some amount of waste as well, and all of those things have environmental impacts. Then once the product is ready for use, it gets shipped to the final destination through some distribution chain. And maybe, like in this photo here, there is, maybe it's an electronic access system, and so then it uses energy throughout its useful life, and so maybe this device here has a constant draw of electricity, and that has to be accounted for. Finally, when the device reaches its end of life, it's either disposed of in a landfill or recycled or reused in some other application. So that is a brief overview and example of a door hardware system. Now let's get into a little bit more detail. Let's take that door hardware life cycle and let's talk about how we would, what is the idea of life cycle assessment on that life cycle. So you have all of these activities that are going on in each stage of a life cycle, and essentially you're counting the inputs and outputs for each of those stages. So let's say, for example, let's zoom in on the manufacturing stage. And we know that the manufacturing process requires electricity, so there's some number of kilowatt hours of input going into that operation. And here's a zoomed in picture of the electricity generating station. And so we know that that electricity generating station has some type of traditionally fossil fuels, some water inputs, some support materials to generate that electricity. And it also has emissions coming out of the station. You have air emissions, water emissions, soil emissions, and all of those emissions contribute to one or more environmental impacts, such as global warming, acidification, smog, and various other impacts as well. And so life cycle assessment takes into account these inputs and outputs for all of these activities at each stage of the life cycle of that door hardware. So why is life cycle assessment useful? Well, customers are very familiar with a lot of single attribute product labels and claims, such as the ones that I've shown on this slide. For example, you have sustainably harvested wood, you have certified recycled content, you have certified electronics recycling, low VOC content, you have bio-based material, low water use, and low energy use during its lifetime. And so these are all useful metrics that consumers can easily identify to make purchasing decisions when they are choosing between different products. And these are very valuable tools for that purpose. But life cycle assessment goes steps further and is a more comprehensive and complete picture of what those environmental impacts will be. So life cycle assessment actually takes into account all of these different things and quantifies the actual environmental impact of the product, and so is a more complete picture of that quantitative information. And Kara is going to talk more about this later on, but as a brief overview, LCAs really do help manufacturers understand where the impacts are coming from in their product system, and it helps them make the products more sustainable. So, for example, they might evaluate a product that is using all virgin material and they want to integrate recycled content. Well, a life cycle assessment can show them what the benefit of doing that would be, or some alternative design change. They might be considering changing their supply chain or distribution chain from a truck-based system to a more rail-based system, and they can see what those impacts would be. Maybe they have identified some chemical of concern when doing the life cycle assessment. Now they can look at potential alternatives and evaluate those against the original material to see what would be a better solution in the product. And maybe they want to take the step of going to a closed-loop design system for their products, where they actually have a take-back program and take that product back at the end of its life and recycle it back into a new generation of that product. And so life cycle assessment can help show the benefits of doing that as well. And of course, life cycle assessment is a big piece of disclosure in the green building industry, and so it is a tool that architects, builders, and green building customers use to evaluate and select sustainable products, and it is used and recognized in several green building standards such as LEED, NGBS, IGCC, and others. All right, so next I'm going to talk about how you can conduct an LCA in your organization. And so just as a very basic introduction, there are two primary ISO standards that outline how an LCA should be conducted. The first one is ISO 14040, which lays out the principles and framework of life cycle assessment, and then a more detailed standard, ISO 14044, describes the requirements and guidelines of doing the life cycle assessment. And these standards outline 4 steps or phases to a life cycle assessment. The first one is goal and scope definition, where you actually identify the product that you're studying, what the system boundaries are for that product, what the functional unit is, how you're going to collect the data. The second step is life cycle inventory, where you actually go out and collect the data, and you make sure that you're accounting for all of the inputs and outputs along for each life cycle stage. The third step is life cycle impact assessment, where you are translating all of the inventory items, the inputs and outputs, into environmental impacts. And then finally, the fourth step is interpretation, where you look at those environmental impacts and you document observations, you make conclusions, and develop recommendations that are in line with the goal and scope of the study. So let's get into more detail for each of those phases of the life cycle. First one is goal and scope. And so ISO says that when you are defining the goal of an LCA, you should state all of the following in the LCA report. So you want to say what the intended application is, why you are conducting the study, who the intended audience is that is going to be reading and using this information, and whether you intend to disclose comparative assertions to other products in the public. And also remember, when you're defining the goal of the study, there are different levels of LCA that may be appropriate for what you're doing. And so one size really doesn't fit all. At a very low level, you could conduct a full LCA, which is very detailed. And so in that case, you would collect data from every single step within the life cycle of the product system. And so that's very resource intensive and can be very costly. This is the type of a study that's usually reserved for large organizations like large companies, universities, governments that have the resources and time to invest in a study like that. The most common type of life cycle assessment is what I call the commissioner-centric LCA, and that's where you collect primary data from the manufacturer or the commissioner of the study, and you use secondary data sets for most of the other upstream and downstream processes. At a slightly higher level is a streamlined LCA, where you may use primary data if it's available. So let's say you are tracking energy, water, waste, and enterprise system like SAP at your company, and it's easily obtainable from that system. Maybe you want to plug that primary data into your model. But then for any gaps, you probably are going to be using secondary data and perhaps even using a larger cutoff threshold so that you can do the LCA in a quicker fashion. And then finally, at the highest level, there's what's called a hotspot analysis, and that's when you're really just using secondary data sets that are already out there, and you are modeling most of the major system processes and doing it very quickly and at a high level. So this is usually useful if you just want to take a quick look and identify what you think are going to be the major environmental impact drivers for that product system. So when you're defining the scope of a life cycle assessment, ISO says you also have to consider and clearly describe all of these items listed here. So you want to describe the product system, what the function of that product is, and along with that, how you're measuring that function, so the functional unit, describing the system boundary and what is included in that boundary, if you're going to be using some type of allocation, what the procedures are going to be, what methodology you're using to quantify those environmental impacts, and what those impact categories are going to be, what interpretation method you're going to be using, what are the requirements on data quality if you're using secondary data sets, and even for your primary data that you're collecting, what assumptions are you using. If you're making any subjective value choices, those really need to be clearly described. What are the limitations of the study? Because all life cycle assessment studies have some limitations. If you are intending to have the study critically reviewed, you want to mention that, and also describe the type and format of the report that you plan on producing. When we're talking about scope, you've probably heard of different terms like cradle to gate, cradle to grave, and so I want to briefly describe what those mean. Cradle to gate means it's considering raw materials extraction all the way through product manufacturing of that product. So it ends at the shipping gate of the manufacturer. And it's important to note that this is the minimum required scope required by LEED. So if your company is trying to help LEED projects earn that EPD credit, this is the minimum scope that they need to do. Cradle to grave is much more comprehensive, and so that considers all life cycle stages, raw materials extraction through end of life. And so this is really the most valuable type of life cycle assessment because it does give a much more complete picture of the environmental impacts of the product, and it really is the only basis that can be used for comparison between one product to another. So it is a much more complete picture. You might also have heard of gate-to-gate, which really is just considering a single step of the life cycle. So, for example, you might just consider the manufacturing step, and so the beginning gate to the end gate. You might have heard of cradle-to-gate with options, which is just that minimum cradle-to-gate I described before, but maybe you have some additional miscellaneous information that you want to add on but you don't have all of it. So you might just have end-of-life information, or you might just have installation information, and so you want to add that onto the life cycle, and that's called cradle-to-gate with options. All right, the second step in a life cycle assessment is the inventory analysis. And this is when you actually want to go out and collect the data for all of the inputs and outputs, for all of the processes and life cycle stages, and you want to make sure that you're accounting for all of that material and energy. So it's a good idea to develop a process flow diagram showing all of those inputs and outputs of the life cycle. So that's a great way that you can visually account for everything and make sure that you are accounting for that. But it is a best practice to visit the facility where you are collecting primary data to make sure you have a thorough understanding of the product system and to make sure you are accounting for everything that you need to. So you do want to make sure that you collect data for raw materials, energy, emissions, waste outputs for each of the process steps. And then once you have that data collected, you can usually calculate those quantities per unit of production or per unit of whatever the functional unit is. So if the manufacturing facility is producing, if they measure their production in tons, maybe you say there's so many kilowatt hours per ton, for example. Okay, so data collection, it really is the most critically and potentially time-consuming part of an LCA, depending on what the product system and the scope is. And as with any technical analysis or modeling, it's important to remember that if you put garbage data in, you're going to get garbage results. So it really is important to make sure that the data you're collecting is accurate for the life cycle assessment in order for the results to be useful. So to achieve that, you want to make sure your questionnaire is specific to the operation being analyzed, and use that material and energy flow chart that I described before to make sure the data that you're collecting is relevant and is accounted for. So all of those inputs of materials, if there's any ancillary materials that are being used that aren't directly in the product, any energy, water, other physical inputs. You want to account for production, also any emissions and waste. If you're looking for examples of a questionnaire or a data collection sheet, those are in an appendix for ISO 14044, so you can refer to that document for examples. The third step in the life cycle assessment is the environmental impact assessment. So most LCA practitioners these days, thankfully, get to use software to model these inventory flows, and that makes things a lot easier. LCA practitioners used to use either spreadsheets or even before spreadsheets did these in a more manual way, but which takes a lot of effort. But thankfully, these software packages are available now, and the predominant ones used in the United States, at least, are CIMAPRO and Gabi. So you've probably heard those terms, and those are the biggest names. Certainly, there are others as well. And what the software does is it uses secondary databases to map these inventory flows that you've collected, and it maps those to materials and chemicals which have some impact on the environment. So it maps all of those things. For example, it maps CO2 to the global warming impact, and it automatically calculates that for you. There are different impact assessment methods, and that's also why software is valuable, because you can easily switch between those methods and you don't have to redo all the calculations. And it's important to also understand that these impact assessment methods are continually being updated as science regarding those environmental impacts improves. So there's different versions of these impact assessment methods coming out all the time. And the most common impact assessment method used in the United States is the one that is developed by the United States Environmental Protection Agency, which is called TRACE. Stands for Tool for the Reduction and Assessment of Chemicals and Other Environmental Impacts. And TRACE considers all of the environmental impact categories that you see on the screen here. Before I move on to the fourth stage, it is important to remember that there's no such thing as a perfect product. Most products and materials have many environmental impacts before they even come into our facilities or into our hands when we purchase them. So, for example, some of the things that we don't typically think about when we think about products is the raw materials extraction. So, when you're drilling for natural gas, when you're mining metals and other minerals, if you're fertilizing fields for bio-based products, these all have significant environmental impacts, and it's important to remember that one of the benefits of doing life cycle assessment is that it does allow a more complete and comprehensive quantification of those impacts compared to single issue metrics. So the final step in a life cycle assessment is interpretation. So at this point, you do have the environmental impact results, and you want to make some observations, draw some conclusions based on those observations, and then make any recommendations to improve the product or operations that are in line with the goal and scope of the study. Because after all, identifying areas for improvement is really a big reason that you would do an LCA in the first place. So obviously, life cycle areas, processes, and events with large impacts are candidates for improvement. But also remember that good initial targets for improvement are also those where you have large improvements that are possible, but where you can also have minimal resource expenditure and low risk to implement those improvements. LCA results and recommendations are also just one input in an overall decision-making process. You're still going to consider cost-benefit analysis. You're also going to consider quality and performance in your product as well. Lifecycle assessment is really just one additional data point that you can use when designing your product. And for those that have never seen lifecycle assessment results, here's an example. This is from an environmental product declaration that was published a few years back for a countertop surface material that's made partially from recycled glass. You can see the 5 environmental impact categories that were measured across the bottom of this chart, and for each color in the bars represents a different stage in the life cycle. So the blue bar, production, that represents raw materials extraction as well as manufacturing of that surface product. And so it's not necessarily surprising that that represents most of the environmental impacts for each of those 5 categories. It looks like the next largest impact in those categories is the green bar, which represents the construction or installation stage. And that's because there's quite a bit of scrap and waste that's generated during the installation. And then the third highest bar is the red one, which is product transportation, which is the distribution chain between the manufacturer and the installation site. It's also useful to note that the use phase and end of life for this product are actually very, very small compared to the other stages in the life cycle. And that's not uncommon, especially if the product doesn't use any energy or doesn't require much maintenance during its life. Here's another example of life cycle assessment results. And this is from a government source. This is from the Building for Environmental and Economic Sustainability, or BEES program, that is hosted by the National Institute for Standards and Technology, and I've included a link here if you ever want to go and explore this further. But this is a chart showing the global warming impact for various cladding systems on a building, and you can see that they've broken this down into different contributors to the global warming impact even. So you can see that there's based on the color, there's different emissions that contribute to that impact. And so there's lots of building products that exist in this database that are it's free for anyone to go and reference. And finally, I do want to emphasize that transparency is critical to life cycle assessment. Because life cycle assessment does have inherent complexity and inherent uncertainty in the data and methods, you do need to make sure that you are clearly communicating all assumptions that you make, what the boundaries are, what data you're using, what the methods you're using are, and all of those should be very transparently disclosed in your life cycle assessment report. so that the people that are reading and using your results clearly understand what it means and how it applies and what the limitations are. So with that in mind, I will transition over to Kara, and she's going to talk about why life cycle assessment is useful. Kara?
Thanks, Jim, for that great overview on LCA and the LCA process. Now, I want to talk about something that gets me really excited about LCA, and that is to talk about just how to really use and get the real value out of using life cycle assessment. Now, there are many benefits of conducting an LCA. As many of you know, the future of green buildings and eventually all buildings is that architects and builders will be able to look at environmental impact information for most products and use that data as an input to product selection. LCAs can contribute to a lot of various green building standards, and it's not just LEED, as many of you are familiar with. They're also recognized in the National Green Building Standard as well. And LCAs also satisfy requirements of companies and organizations that have sustainable supply chain requirements. For example, C.D. Richard Ellis and the General Services Administration, or the GSA, they both have requirements and are training purchasing managers on how to use LCA data to purchase environmentally preferable products. In fact, I have a client who just very recently lost out on a multi-million-dollar sale because they haven't disclosed any transparency information on their products. Had they had maybe an LCA or an EPD, they would have made that sale, but instead the customer went with a different competitor instead. LCAs are also a valuable internal tool. Product design teams can use this information to evaluate any product changes, and they can really look into reducing impacts right from the beginning of the development stage. And an LCA can can identify very specific areas to target in your operations processes as well. And these improvements often translate into some pretty substantial cost savings. So one of the environmental impact categories that people are most familiar with is a product's carbon footprint. And a carbon footprint is the total amount of carbon dioxide as well as other greenhouse gases that is emitted over the full life cycle of a product. And greenhouse gases like CO2 are produced from many different activities. One example is combustion of fossil fuels during transportation. Or like the calcination of minerals can also produce CO2 in the manufacturing process, which these results could then drive a product's carbon footprint. Now, as greenhouse gases can contribute to climate change, identifying drivers of a product's carbon footprint could be a good first way to identify areas of focus for product development or manufacturing. But carbon footprint is just one example of an environmental impact that you get results from for an LCA. LCA looks at a multitude of environmental impacts. The Tracy impact category, I believe, has 10, focusing in on a few impact categories, or if you notice drivers that are driving all of the impact categories, those can really help you to focus in and target opportunities to reduce impacts. Now, when you look at manufacturing operations, you really have to look at operations in a holistic manner and realize that your operation is a system of many subcomponents of machines and equipment and sub-operations. And if you've ever been involved with collecting data or developing an inventory for an LCA, you know quite how extensive the data collection can be. We require things like energy consumption of natural gas, propane, electricity, water consumption, what water treatment chemicals are used in your water, what types of waste and where the waste is being derived from, what emissions are being emitted during the process, as well as things like packaging and what the materials that your packaging is comprised of. And depending on the product or the operation and the study itself, the level of detail for that data collected can vary significantly. but your operations team should at least be able to see some of those results of the manufacturing-specific lifecycle stage in the environmental impacts. And if you have conducted an LCA and they haven't seen that or studied the results, that's a great first step, would be to educate the operations team about the LCA and really to frame the importance of reducing those impacts and the direct effect it will have on the company's green messaging, as well as it'll help drive operational cost savings. And when Jim and I conduct LCAs, we usually visit the manufacturing facility to make sure we really understand how that product is being produced. But also we want to make sure that we're including everything that we need to in the LCA study. And as we're walking through operations, we try to use our perspective as an outsider just to identify just basic and preliminary opportunities to reduce some of these environmental impacts. And we understand there are many, many types of operations as there are manufacturing plants. Each have their own unique conditions and requirements, but there's always opportunities for improvement and reducing environmental impacts, and LCA is a good way to help identify some of those opportunities. So here's a great example of some results that we've helped our clients realize when we've been conducting an LCA. The scope of this study included a detailed assessment of the operations during the data collection phase of the lifecycle assessment. And we really wanted to identify some potential opportunities to reduce these impacts during the process. So while we were at this facility, we noticed that the water consumption during the operations didn't really add up to the high amounts of water that they were actually consuming. And after we reviewed the benchmarked water data over the course of a few years, we noticed that the currently high water consumption compared to previous years, it didn't quite make sense. So this led to an investigation by some process engineers of the water flows in the process, and at which point they did find a water leak. And when they fixed it, they saved over 4 million gallons of water per year. But we also inquired about their energy usage and their thermal oxidizer, which they hadn't tuned in a number of years. And just by tuning that equipment, which is not that expensive to have performed, they saved almost $200,000 in just that next year from reducing their propane usage by 20%, which was a huge cost savings for the facility. And based on that, we were then able to update the lifecycle assessment based on the new inventory results a year later. And this client of ours, they then published the results and the opportunities. And because they published this result after it was critically reviewed, they were able to make a very large sale just a few months later, since the customer was looking for a product that had LCA data and that had the supplier showing sustainability initiatives. So as part of conducting a lifecycle assessment, it is possible to conduct more detailed facility assessments alongside the data collection, as we just witnessed with the former case study. And a sustainability assessment, for those who may not be aware, it can be used to benchmark operations and really help organizations identify opportunities to reduce resources like energy, water, and waste, as well as various other resource uses like packaging. And by reducing these impacts via the opportunities determined in an essay, an organization can really look to reduce the life cycle impacts of the manufacturing process of their products. So another avenue that you can really use LCA for is sustainable product development, or sustainable product innovation, SPI as we call it. And sustainable product innovation is a concept of using life cycle thinking and integrating sustainability into the product design and development process at your company. Now, while many companies are conducting LCAs and they're publishing EPDs just to fulfill that lead version 4 credit, the intent of that credit is to get information out publicly for now. However, the next phase is for manufacturers to use this data to design greener and more sustainable products. Just because you have an EPD now, that's great to meet that credit, but it's not going to be long until the design community is starting to ask you, how are you making your products more sustainable? For one example, Architecture 2030 is an organization that has goals that many architecture firms have signed up for, looking for companies that have dramatically reduced their impacts in their building products. And their goal is to select products that have a 50% reduction in their carbon footprint by the year 2030. So SPI can involve a lot of activities, and an important one is thinking about the risks related to the materials that you use. So, for example, what is your company heavily reliant on to provide your products or services? Is it fossil fuels? Is it oil, minerals, specific metals? And it also helps you think of the present, but as well as the future. So some questions to ask for your research and development team is, what resources are we dependent on for the sustainability of our company? What will be the cost and the availability of these resources in the upcoming years in the future? And what are the alternative resources to ensure that we stay competitive and can supply the market in the future? Lifecycle assessment can help you identify risks in the upstream and the downstream of product manufacturing in terms of environmental impacts that you may not even realize are risks to your company. So, for example, a lot of products have this present system in place, which is a cradle-to-gate system, as Jim had explained earlier, which we like to think of it as a take, make, waste economy, where raw materials are extracted from the earth and are manufactured into components that are then assembled into a product, where the product is used and disposed of. And each stage in the life cycle requires energy and labor and material resources. And then with each stage, there's also emissions and waste. Sustainable product innovation really looks at integrating sustainability across all life cycle stages with the goal of improving long-term competitive advantages. So instead of just having a cradle to grave, try having your team look at the different manufacturing steps and see how they can change the system. So for example, here at the product end of life, if you can make your product maybe more recyclable or incorporate a take-back program, you can then use those materials again in the manufacturing stage instead of continually extracting raw materials from the earth. Now, gradual improvements in any of these stages is great, but if you also ask your R&D team more fundamental questions about your product, like what function or service does this product really provide to our customer, and is there a more efficient or less impactful way to provide this exact same service? Fundamental questions like that are addressed in like a systematic way can really enable revolutionary product design changes, and it can create a huge value for your customers as well as a huge competitive advantage for your company, while at the same time it allows you to become a responsible steward of the product system and reduces LCA impacts for the future. So here is one example of how one of my clients has used LCA in their product development program. And this really helped them justify increasing the amount of recycled content that they used in the product. So initially, a life cycle assessment was conducted that showed the main driver of the impacts was raw materials. And if you can see here in the blue, this was the baseline life cycle assessment that was performed, showing the environmental impacts at 100% each. And they looked into various ways to reduce this impact, and one option was that the product development team found a way to integrate a large percentage of recycled content into the product formulation. And by incorporating recycled content in, the operations didn't have to change, and the product performance also was not compromised. But just by incorporating recycled content into the product, they were able to reduce the environmental impacts in the 5 categories that are shown here, from anywhere from 8% in eutrophication all the way to 64% in ozone depletion. And now the team isn't finished looking for ways to reduce environmental impacts of this product. They're now focusing in on the operations to continually improve that footprint as well. So integrating LCA into the new product development process can really provide value for your company. Tools such as like a sustainability product development guidelines and checklist that can be integrated into your design process, such as StageGate, where if you can use the results of an LCA or if you use like a hotspot LCA, they can really help develop second generation products and this could be a really powerful tool. And new ideas can emerge with the collaboration of SPI that can really revolutionize a product. One item, though, that is vital in this is to incorporate training. Training employees on LCA and how to use lifecycle thinking in the new product development process, that's vital. Employees who receive proper training can really use this as a helpful tool. However, if they don't receive training, team members will probably just deflect this as like another requirement that they'll have to do, and they won't really understand the value and be able to use LCA during their role. So now I want to talk briefly about EPDs, as many of you listening are really probably interested in publishing an EPD to fulfill certain green building standard credits. As many of you know, LEED version 4 has been a huge driver of EPDs for building products. To be clear, architects and builders are not waiting for LEED version 4 to be phased out. There are actually pilot credits in LEED version 3 that have EPDs that architects and builders are using to help achieve LEED certification. So they're not waiting on LEED version 4. But LEED isn't the only standard that is looking for LCA information. The National Green Building Standard, NGBS, as well as the International Green Construction Code, both currently in the final stages of their updates in 2015, will probably recognize EPDs in these new versions. And NGBS already has a lifecycle assessment practice in the 2012 version. If you are a building product manufacturer and you haven't been getting requests for something like this, you probably will very soon. And it's really worth asking your organization how will you approach this and answer those questions from your customers. So when we're talking about lifecycle assessment and EPDs, there's a lot of acronyms, and it probably sounds like alphabet soup. So there's a series of acronyms that I'm going to try to explain and to help you learn what it is. So in order to publish an environmental product declaration, you need a PCR, and a PCR is a product category rule. A product category rule is then used to help create the LCA, and then an EPD can be created using both a PCR and an LCA. So I'm going to try to explain that a little bit better. So an EPD allows a company to provide transparent LCA information, and it discloses environmental impacts, but it also protects the business interests and the proprietary data of the manufacturer. And they're formal reports that are critically reviewed and verified by a third-party expert, and they follow ISO standards 1440 and 44, as Jim has mentioned, as well as ISO standard 1425, as well as a product category rule. And in order to maintain consistency among different products and manufacturers, a PCR defines certain assumptions such as the functional unit and what that should be for a category of products. Other items are defined in the PCR. Some examples could be the installation scrap rate, data set model selections, what to assume for disposal scenarios, and also what to disclose in the EPD. Using those guidelines set in the PCR, you can develop an LCA on a product. And then the LCA report is submitted to a third-party critical reviewer who provides a review according to ISO standards and the PCR. And when the LCA is approved by the reviewer, then you can develop an EPD based on that study that follows the guidelines set in the PCR. So with that, now that you know what an LCA is and how powerful of a tool it can be, I really think consider how LCA can benefit your organization. Determine the feasibility and the buy-in from relevant business managers and assess your available resources. Then try to plan and execute an LCA, but don't just conduct an LCA without realizing its true potential and value. Integrate its results into product design and operations as well as your marketing. Train your sales team on how to use an LCA to really reach your customers, as well as provide training to others throughout your organization on what LCA is. And with that, I'll turn it over to Caitlin.
Thank you so much, Jim and Kara. I'll quickly wrap things up. You now should be able to understand the growing demand to quantify and publish lifecycle environmental impacts. Understand how lifecycle assessments are a core component of a sustainable product innovation program. Improve the environmental performance of a product beginning with product inception. Utilize lifecycle assessment data to evaluate products and suppliers. And utilize lifecycle assessment data to improve operations and reduce environmental impacts. I'm seeing that we have a lot of really great questions coming in. Please continue to send your questions in, and Jim and Kara will be happy to answer them. I'm going to turn it back over to Jim now to answer a few questions.
Thanks, Caitlin. I'm just looking through the chat window here to see what the first question is, and it looks like the first question is, how much does LCA software cost? Well, that's a great question, and I do just want to say that Sustainable Solutions, we don't officially endorse one software over another, but there are various options out there, and there's actually even a free option. It's an open source LCA tool called OpenLCA, and anyone can go and download it for free, and that's available at no cost. But if you're looking at the typical packages of SimaPro and Gabby, I mean, that's going to, of course, depend on the options that you choose. I think they also offer subscription options. But if you just want to go purchase a couple of licenses for your team, it's usually going to be somewhere in the neighborhood of $20,000 to $30,000. Of course, there may be additional costs for annual maintenance. Also, they may offer specific data sets that are valuable for your industry, and so you might want to purchase those as well. So it really depends on how big of a license you're looking for, how many licenses you're looking for, and how much data you need. All right, the next question that I see is, my company makes hundreds of products. How do I decide which products to start with? Another very good question, and a lot of our clients are in a similar situation, and depending on what resources you have available and what data you have available can really determine how you approach this question. So if you're in a situation, well, the first thing that you might want to do is just take a look at your sales data and also align that with where the most customer requests are coming from. So I'm sure your sales and marketing teams will have some knowledge of where they're getting requests for lifecycle assessment information and what products those are. And so you can also then take a look at where you are, what products you're selling the most, and maybe also what products you're selling the most into the green building world or some other area where LCAs are in demand, and really identify some of the some good overlap between those things to get you started. But it might also depend on your manufacturing footprint as well. I mean, if you have several plants that you are where you're making products, and let's just say you have 5 plants across the United States, and maybe one of those plants produce 50% of your products. So that one plant may actually be a good place to start with LCA, because you can collect one set of data for energy and material inputs for that plant, and then allocate those inputs among the various products that are made at that plant. And in that way you can get the most bang for your buck, so to speak, when you're allocating resources to this life cycle assessment study. You may also, if you have more resources up front to invest, you may also think about developing more of a detailed data collection plan and actually develop a parameter-based life cycle assessment model. And we've helped organizations do this as well, where they have many, many different products, and they can build the LCA model in such a way that they can change the parameters of that model and actually generate life cycle assessment results for dozens or even hundreds of products based on that life cycle assessment model. So that may take a little bit more effort up front to build it, but you know, in the end, it can definitely be a great value in the end. I hope that answers the question. So the next question I see is, do you always have to compare LCA results to another competing product? And well, the short answer is no, you don't. And often what you'll see is in published life cycle assessment results, they're just published on their own with numbers saying what the environmental impact is for the various impact categories. But to someone who is not a LCA expert and hasn't seen LCA results before, it's really hard to know what those numbers mean. So oftentimes it is useful for the commissioner of a study to compare their results to something else that is either very similar to their product or something else that they have some awareness of is in terms of environmental impact. And so usually when you're, you know, when we develop results, we might develop some comparison, but just to share with an internal audience, definitely not for publishing, just so they can get an idea of how their product stacks up to something else that they're familiar with, because otherwise those numbers may not necessarily hold a lot of meaning for a lot of people. The next question I see is LCA used outside of green building? And that's a great question, because I know we spent a lot of time talking about green building today, and that's because the green building industry is a big driver of life cycle assessment, and that's why we talk about it a lot. But it's not just the green building industry. There are lots of other industries that are using life cycle assessment. You know, things that come to mind are electronics products. I know I've seen EPDs out there for printers and laptops. So I know that consumers are interested in LCA information for electronics. I know that life cycle assessment is growing rapidly in the food industry. Some various food products now have life cycle assessment and the upstream impacts of those foods. If you go onto YouTube and search for Toyota Prius life cycle assessment, you'll see that Toyota is using LCA to measure the impacts and benefits of their Prius hybrid vehicle. So it's being used in the automobile industry. Consumer products, you know, lots of retailers have formed a group called the Sustainability Consortium, and they are currently developing various indexes called sustainable product indexes for different categories of products that they sell in their stores, with the intent of collecting data from their upstream suppliers and really driving sustainability within their supply chain in a life cycle assessment based way. Kara also mentioned government use. The General Services Administration and the Department of Defense are using life cycle assessment to make purchasing decisions, not only for products but also determining systems that they develop internally and what decisions they should be making and based on life cycle assessment. LCA has been used frequently in the biofuels and energy systems industry because there's a lot of questions about whether or not biofuels are actually better than the fossil fuels that they're replacing. So there's a lot of LCA studies out there for biofuels. And also infrastructure. The Institute for Sustainable Infrastructure, or ISI, has developed a standard called Envision, which is somewhat similar to the LEED standard, except it's for infrastructure projects, and it does recognize lifecycle assessment in that standard. So I mentioned several here, but there's definitely other uses of LCA outside of green building. And it looks like we're actually running out of time here, and I don't see any more questions coming in, so I'm going to transition this back to Caitlin, but I want to thank everybody for attending today. Thank you.
Yes, thank you all for attending today's webinar, Advancing Your Business with Lifecycle Assessment. I will be sending out a recording of today's presentation and the presentation slides to everyone who registered and attended. And please feel free to contact Jim and Kara with any further questions. And also, if you would like this presentation to be presented to your specific company, we can also do that as well, so please let us know. And because of our successful May Corporate Responsibility Revolution Strategy to Success seminar, we are having another one on January 28th. Even though early registration has ended, we have a few seats available, so please register as soon as you can for this upcoming seminar. It is a hands-on, action-oriented workshop that will help all attendees create and implement a corporate responsibility plan that will support your business strategy. For more information, feel free to email me, or you can also click on the link on your screen. And one last piece, please sign up for our next webinar, Vision to Value, on December 18th, and this will be conducted by Tad Brzezinski. Thank you all, and have a great day.